Welcome to this technical walkthrough of P.A.L.O framework. This session demonstrates the operational deployment of the PALO-AI Agentic Governance Layer, engineering to enforce strict control boundaries before any autonomous agent execution occurs. We begin at the official portal paloframework.org. The core objective of this architecture is to make autonomous agent authority completely visible, testable, and reviewable. PALO-AI operates as an emergency governance control plane designed specifically for N88 and advanced agentic automation platforms. It eliminates blind trust by establishing an explicit control path. Every agent action proposal must systematically pass through 4 sequential phases: claim, normalization, policy evaluation against active constraint, human-in-the-loop approval when risk thresholds are breached, and immutable recording for cryptographic evidence. This structure ensures that the action is either explicitly allowed, flagged routed for review, or definitively blocked before any code is executed. The framework provides 3 distinct integration routes into the exact same underlying governance contract, accommodating different infrastructure requirements. Route number 1 is the code-first development path, enabling direct integration, JSON schema, MCP parameters, and CI gates into broken executors. Route number 2 is the no-code or low-code builder path, allowing engineering team to plant explicitly visual decision gates within automated workflow before production graduation. Route number 3 is the rapid prototyping path, utilizing platforms such as P.A.L.O Studio to test stricter tests of the MCP tools without anything policy code deployment. Shifting to the implementation layer, we examine the structure of the N98 nodal PALO-AI package. This developer preview node acts as concrete interface within the automation environment. The configuration requires explicit credential mapping, defining the gateway URL and the secure baker token to establish authenticated authentication within the P.A.L.O gateway. The operation exposed are divided into 2 main vectors, proposing an action for real-time validation and resuming an action after human approval sequence has cleared. The output map directly into 3 deterministic governance states: allowed, approval required, and denied. This node remains full compatible with Node.js 20 or never, guaranteeing an hardened runtime environment. The entire lifecycle transition from initial intent to verifiable outcome through a standardized 7-step architecture: propose, normalize, evaluate, approve, execute, record, and verify. This architecture decouples the execution layer from the governance layer. Looking at the deployment choices, local deployment remains entirely possible via local sidecar architecture, which keep credential register and ledge strictly the hosted host. Alternatively, the cloud can be configured as strictly governance service boundary. This structural separation ensures while agent deployment remains highly scalable, policy deployment borders remain rigid and uncompromised. The platform capability matrix outlines how different orchestration environments integrate with the visual gates, broken execution vector, and runtime inception. Whenever a deployment originates via local alpha node or simulated across platforms like LangChain, LangGraph, RedNote, or Make, the underlying governance mechanism remains constant. Integration is strict into enforcement. If a platform like runtime inception, the P.A.L.O broker control path step into enforce to boundaries, preventing agent from acting as everything high privilege entirely within the network. Before reviewing the live execution, we address the exact scope of this release. This developer preview focuses heavily on establishing N18 visual decision gates, governed executor, and secure approval resume mechanism. To bridge the gap to full production scale, explicit requirements such as OADC, anti-LLM, identify alignment, KMS, backend cryptographic signing, and formalized threat modeling must be finalized. This ensures an evidence-driven progression from prototype validation to entire enterprise secure hardening. Let's analyze the technical contrast between an ungoverned agent and the P.A.L.O governed agent. On the left side of the architecture diagram, we see the traditional vulnerable path, direct tool execution without P.A.L.O.AI. Here, the agent directly selects a tool, credentials are provided immediately, and the execution proceeds straight to the target system. In this model, possession of the integration credential becomes synonymous with absolute permission. The system has zero visual authority, zero upfront policy enforcement, and yield only partial obfuscated post-facto logs. Out-of-the-scope action will succeed because there is no gatekeeper. Now, contrast this with the right side. Governance execution with the P.A.L.O.AI. The agent cannot touch the tool directly. It generalizes an action proposal. This proposal passes through the P.A.L.O.AI control gate. It is normalized, executed against the active policies, and checked for mandatory human verification signatures. Only when a session passes time-bound, cryptographically signed token issued to permission execution. If the agent attempts an out-of-the-scope action, the proposal is incepted and blocked at the gate. Authority is made completely explicit. Moving to the terminal deployment, we initialize the backend services required to power the governance gate. We export the local environment variables including the gateway token path and server parameters. Running npm run server within the repository spin up the P.A.L.O gateway instance. The console logs confirm the P.A.L.O.AI development preview server is live and listening and designer network interface. An agent required begin to circulate the terminal display real-time inception log, capturing the exact meta tag of the incoming action proposal before they are routed through the evaluation engine. Switching to the Canvas editor, we visualize how this logic behavior inside an orchestration workflow. The layout separates the unvalidated execution path from the hardened P.A.L.O governance path. When the execution trigger fires, the request is intercepted by the P.A.L.O governance node. If the policy demands the human confirmation, the execution is suspended. A state claim is generated and the workflow enters in the secure hold states. This visual layout provides administrators with a real-time overview of the active, approved, and blocked agent behaviors across the entire enterprise ecosystem. Let us review exactly the structural data of denied execution event. The JSON payload on the screen details a P.A.L.O agent policy decision wherever a status is explicitly marked as denied. Inspecting the attribute, we see the operation request as a file read on the resource designed for file support knowledge on the path you see in the picture. The evolution engine rejects this action. The logged reason is precisely no structured profile is registered for this agent in case. The payload demonstrates that without required encryption engine and matching scope parameters, the gateway strictly blocks execution, preventing authorized data for register escalation. Now we execute the full lifecycle demo via command line divided into 4 mandatory operation phases. Step 1, we register a trusted authority profile to establish the baseline identity parameters. Step 2, we intentionally attempt an out-of-the-scope action to verify the gate incept denied unauthorized commands. Step 3, we propose a legitimate, fully scope support knowledge and action which match or registered criteria. Step 4, we bind a secure human decision to this X, immutable claim to authorize the transition. The terminal logs confirm successful compliance matching, demonstrating a completely controlled auditable agentic execution loop. Demonstration is complete. The object remain absolute, protect human agency and secure the automation border. For full technical documentation, resources, assets, please visit paloframework.org and of course the GitHub repository.